Hi everyone, today I will be presenting the material introduced in Chapter 2 of our book. A variable is a named item that holds a value such as x, password, or z. These named items can hold integer or string values. For example, x can hold the integer value 5, password can hold the string value Bob, and z can hold the sum x plus y. Examples of assigning variables in Python are shown here. Here we assign the value of 10 to the variable x, and x is also known as the identifier. For the next line of code, we have assigned the value of x to variable y. We do not need to explicitly write the value 10 because Python will automatically assign the value that is held in the variable x to the variable y. The output is further demonstrated in the console below. Now, what if we want to modify or reassign the value of x? We do not need to go back to the original assignment operation in line 1 of our code. Python allows us to reassign variable values anywhere in the code. As we can see here, we can reassign the value of x to 5. Can we guess what the value of z will be? Let's think this through. Based on the order of assignment, we know that x holds the value 5. However, we must be careful because y will not hold the updated value of x because we did not reassign it. Thus, y will still hold the value of 10. Now, if we were to add in another line of code between lines 5 and 6 that duplicates line 2, then y would hold the updated value of x, which is 5. However, we have not done this, so the original value of 10 will be kept for y. Thus, the sum of x plus y will be 5 plus 10, which is 15, as shown here. So far, we have assigned string and integer values to our variables, but we can also assign floating point values. A floating point value is any number that contains a decimal within the digits, such as 4.235, 0.0259, or 6.38. Here we have assigned a float to value z. We can check the value type in Python using the type function shown here. The console output confirms that z is of type float. The user can also enter a floating point number, as shown here. The user enters a floating point value for the variable miles using the float function. This user inputted value can be arithmetically operated on, and a floating point value will be outputted. If we do not modify the output of a float expression, it can give us back a very long number with far too many leading digits than required or necessary. We can easily modify the number of outputted leading digits using the function shown here. This function is written as f quotes my curly brackets, my float, or the name of the variable, followed by the number of leading digits that we desire. In this case, we chose 2 leading digits, but this number can be adjusted to include more or less leading digits as desired. In Python, arithmetic operations follow the standard order of mathematics known as precedence rules. In our script, we have example expressions that highlight these rules. Expressions within parentheses are evaluated first. For example, we have the expression x plus 2, which is assigned a value of 2 plus 2 divided by 2. This expression would evaluate 2 plus 2, which is 4, divided by 2, giving us a final value of 2. In the next example, we have the exponent and division operators. Exponent operator holds precedence over division, thus the expression x to the power of 4 will be evaluated first, with the result being divided by 2. Now, if we have the division or multiplication operator as well as an addition or subtraction operator in the same expression without parentheses, the multiplication and division operator will hold precedence over the subtraction and addition operator. For example, we have, again, x plus 2 divided by 2. With parentheses, the x plus 2 would have been evaluated first, but without parentheses, the division operator will be evaluated first. Thus, the expression will follow the order of 2 divided by 2, with the result being added by x, or by 2. So far we have created simple programs, but what if we want to create programs of higher complexity? Well, as our programs get larger, it becomes unreasonable to store all of the code's functionality or content in one file. Instead, we can separate parts of the script into separate files, also known as modules. This helps keep the code organized. We introduce the concept of modules using a very simple main script and a very simple practice module script. Our module script, shown on the left-hand side, assigns 2 floating point values, 25 and 3.1599, to 2 variables called gas mileage and gas cost. Now in the main script shown on the right hand side, we can import these variables and their associated values using the import statement shown in the first line of code here. To retrieve the variables gas mileage and gas cost and operate or manipulate them, we use dot notation. An example of using dot notation to access modules data is shown here. We output the statement of your car's gas mileage is followed by the value for the variable gas mileage. We use dot notation to access the value stored in the practice module. Additionally, we can operate on this information to obtain a new output as shown in line 6 of our code. Here we implemented an expression that utilizes the value stored in the gas cost and gas mileage variable to obtain the price of gas for a usage of 20 miles, with the output expression shown here. Python has its own modules that contain predefined functions. For example, Python has a random number generator module. We can import this module using the statement import random shown on the top here. This module contains functions such as random, ranRange, and ranInt. The random function generates random floating point numbers between 0 inclusive and 1 exclusive. For example, the random function generated a floating point value of 0.1, 2, etc. The range function allows the user to specify a minimum and maximum value. For example, passing in a maximum value of 10 generates values between 0 inclusive and 10 exclusive. The maximum value for ranRange is always one less than the specified value. In this case, we inputted a value of 10, so our maximum would actually be 9. We can also specify a minimum value as shown in line 8 of our code. This line of code generates values between 5 inclusive and 10 exclusive. If we want to include the maximum value, we can just use the ranInt function. That's it for my presentation. I hope you all learned something new. Thank you.